Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
At the end of January, NASA announced they're at capacity with respect to the International Space Station, crews, cargo, and systems. But even before that announcement, private companies began developing their own concepts for free-flying space stations, as well as ways to expand the capacity of existing and future space stations. And one of those companies is ThinkOrbital, which is developing the ThinkPlatform that would expand the capacity of an existing orbital outpost. And my guest on this edition of the Ex Terra Podcast is Sebastian Asprella, CEO of Think Orbital. Sebastian, thank you for joining me.
It's a pleasure to be here, Tom. Thanks for having me, and thanks to your audience also for having myself and Think Orbital on your wonderful podcast.
It's absolutely my pleasure. Let's start out just talking about ISAM and what is the Think platform?
Fantastic. So yeah, I mean there's a few acronyms being coined out there, but ISAM in particular is space assembly and manufacturing. Some people would know about it awesome in the past, but effectively it's a way to categorize quite a few applications that are critical for commercialization of space, industrialization of space, and also for defense. And yeah, where we come in with our Think platform, in fact, is a slightly different way to basically manufacture infrastructure in space. Historically, humanity has been manufacturing the sort of the cylinders that you see for the international spaces. This infrastructure here on Earth, as big as you can fit it inside the fairing of a rocket, and then putting them together in space with extravehicular activities. And where we come in is, in fact, we want to kind of do away with the tyranny of the rocket fairing and stack the parts inside the rocket fairing, very much like you see at Ikea, for example, of flat pack furniture, and with a combination of robotic manipulation, electron beam welding, and a few other nice little tricks to be able to assemble that infrastructure in space. And the benefit from that, it may be obvious from the way I presented it, but it's just that you can scale. You can have 4 times the full international volume of the International Space Station, in a single launch, where it took over 40 launches for the International Space Station. And we strongly believe that this is the only way to allow manufacturing industries to be able to access space in a way that is cost effective, in a way that they can benefit from, for example, microgravity to actually do products or parts for products.
So how then does Think Orbital utilize that concept, and what are some of the products that you're planning? I think that the initial Think platform is going to be an expansion module, but then you've got other things on the books as well.
Yes, absolutely. So we have what we like to call 2 major products. So it's the Think Platform 1, which is the one you were alluding to, Tom, and the Think Platform 2. The Think Platform 1, we see it as an expansion or an augmentation for free flyers. It could as well be the International Space Station, but as well many of our friends like the people from Orbital Reef, like Blue Origin and Sierra, as well as Axiom Space, NanoRacks, and Northrop as well. It's a way for them to be able to expand their product offering with large volume for potentially storage, research, or any other things that they would probably need higher volume at low cost. And where our second product comes in, and so the first product would normally be around 300 to maybe 800 cubic meters in space on current launch vehicles. And the second product, which is the ThinkPlatform 2, most likely a free flyer, that provides about 4,000 cubic meters of space using Starship. So it's quite a big leap forward. And the second platform most likely will be used for applications around active debris remediation. And what this means, maybe for the audience that may not be so familiar with this, is that there's quite a large amount of junk, free flying, so orbiting our beautiful planet, and this is likely to get worse. The more we access space, the more we launch satellites. So we need to have a way to be able to mitigate the risk that this junk poses for other existing satellites, even infrastructure that is vital for us, like GPS. So being able to have a big platform like a ThinkPlatform 2 as a way station that can actually capture some of that debris, or can be like a shipyard where that debris is being brought to, and then perhaps for repurposing the debris, either for refueling or maybe deorbiting the whole sphere itself. It's quite an improvement in terms of other alternatives on active debris remediation. And in parallel to that, what we feel the killer app is to be able to manufacture assets in space. And while we are not looking ourselves to manufacture, we're more like, if you imagine, more like a real estate developer in space, where we provide, the infrastructure, the electricity, all the things that you need for you to be able to manufacture. We certainly see that as potentially the killer app to be able to support other companies, be it, smaller startups to, fully fledged big manufacturing organizations, for them to be able to access space, to commercialize the products, and be able to reap the rewards of what this new space economy will bring to Earth. I think overall, I can go a little bit more in details if you're interested.
I think we can do that in a little bit, but I'm getting the picture in my head because I'm old. And, when you watch things like the Star Trek movies, and they had their big space docks and assembling enormous spaceships in space with a lot of people around. But the concept that you have here is it's going to be done far more robotically, and maybe not have quite the risk to people as they go up and try to manufacture on a small scale here, and maybe in the future something much larger.
Absolutely, yes. So perhaps giving a little bit of background, we believe that the future of humanity is in space. It's a high frontier, it's the next destination. I think we're natural explorers at heart. And one of the bottlenecks that we see in the future is that sort of space in space, that large volume space, not so much for human-related activities, because that I think is relatively covered, at least for the next maybe decade and a half, but very much when it comes to industrialization space. And we've seen historically the bottleneck has been on launch, but thanks to the likes of SpaceX, and we have, some team members that are ex-SpaceX, and thanks to them very much about, how far they have gone and how much cadence we have with launch now, and reliability, and especially now when Starship comes online, and how much we can put up into space. But the challenge will be, what do we do next? And in terms of what do we do next, definitely we need to have those large volumes in space. And when you start thinking about how hazardous space is towards human life, then and in parallel to that, thinking how can you de-risk being able to provide that infrastructure cost effectively, faster. That's why the use of robotic capabilities and the technology has gone so far these days that it's no longer it's no longer our biggest challenge, the technical side or the engineering side, to be able to have the ThinkPlatform operating in space. We're looking at 5 to 7 years from now, one of the big ThinkPlatforms here.
When you talk about being basically a real estate developer in space, I'm thinking that are you going to be basically putting up a shell and then, as they say in the real estate business, build to suit? And who does that build out on the interior of the spacecraft?
Yeah, I think that's a great question. So we see ourselves as a real estate developers in space. We do see some operational activities, for example, annual maintenance and providing all the utilities that you would need to be able to basically do your business in space. Now, regarding the interior fit out, there are some elements that we will most likely develop ourselves as well, especially when it comes to slightly simpler feed outs. But for sure, one of the areas that we are not planning to dive into would be the actual machinery for you to be able to manufacture in space. The actual process, and let's say if you're looking at, I'm not sure, the details around it, whether if it's to do with semiconductors or even organs. So these kind of technologies we're not planning to develop ourselves, but what we are working towards is with partners that are planning to do that, to be able to provide them the environment that they need, to be able to provide them with the stability that they need. So that suit, or that, as you call it, I think nicely, that suit, that casing, it's tailored to, for them to be able to go and bring in their machines, and the things that they need to be able to for them to do their business.
How did Think Orbital get started, Sebastian?
That's a great question. So we're now 3 co-founders. We were originally 2 until not that long ago, and I think it's a mix between a passion for exploration, as I mentioned earlier, a passion to solve real-world deep tech engineering challenges, and I think a possibility to be able to accelerate humanity's access to space, accelerate the commercialization of space. And all of this, funny enough, came together during, full lockdown, COVID lockdown. And whereas one normally would be part of forums and, activities that would require human presence, I met with my first co-founder, Dr. Hulub, who also came out with a founding thesis for ThinkOrbital on a very obscure deep tech space engineering forum on Discord, and it was kind of love at first sight. He was looking for somebody who had an understanding of engineering, but also had a very strong business understanding as well. And I was looking for somebody who had some understanding of business, but a deep understanding on the engineering side.
Right.
So and from there, ThinkOrbital was funded and started operating April 2021. So we are not far from 2 years now, and Tom, it's been a blast. It's been just amazing. I could have not dreamed how many wonderful people I've met, like yourselves. We had over 200 discovery calls, and the team has been growing now. We're 13 team members strong. We have an amazing group of 7 advisors, and it's just and so many partners and friends across the industry. It's just wonderful, really, truly wonderful.
What was the process like trying to convince investors that you had a product that you could actually get into space?
Well, I think in one hand, the investors we have so far, they approach us them wanting to invest. Mm-hmm. And these are mostly who became our advisors, even team members. So people who had a deep understanding of who we are, at an individual and a team level, who have a deep understanding also of our technologies and the way we're actually building up ThinkOrbital. But we grew from there. I mean, we have we moved from a little workshop in Portland. We have our headquarters in near Denver, in Colorado, where we have a lab and an office. We've also done smaller prototypes, which I'd love to share with you a photo. And we won a couple of contracts for the US Space Force, which we have delivered successfully. So there's quite a lot of things that we have done. And we wanted to do that in a way because we want to obviously achieve our mission. We want to grow ThinkOrbital, but also we wanted to de-risk the subsequent investors as the investment fund would be bigger in itself. But having said all of that, we understand the market conditions. So it's challenging in one hand, but investors understand that, especially in the market conditions that we're now, if you were to invest your hard-earned dollars, you're looking at investing in something that would actually give you a return after the conditions have ameliorated. And normally that's where you go for a slightly longer time horizon. And that's where deep tech, especially space, that would normally take at least 5, maybe 7 to 8 years to mature. It's a place where investors normally look at investing, especially in the current conditions that we're in.
Did your ISAM concept come from a clean sheet design, or is it existing technology? Did it come from NASA's technology sharing program? Where did that? How did you come up with the concept of how you're going to build in space?
It's the integration of all this technology, what we call the ThinkPlatform, or originally the Orb2, which is what you see on this side. Mm-hmm. That's a clean sheet design. So it's something that we came up with ourselves, but it would be unfair to say that are there any clean sheet designs? I mean, we're standing in the shoulders of giants, right? So when you started looking at all the subsystems that we have for ThinkPlatform, you have robotic manipulation, which has been used quite extensively in the International Space Station with the Canadarm. You also have electron beam welding technology, which is used quite widely here on Earth, although you require high vacuum. It's also been tested by the USSR, although at a much lower voltage, and so on and so forth. So is it completely clean? Maybe, maybe not. But for sure, we want to utilize let me backtrack a little bit. So when we look at the product, for me, there are three key pillars. And in the middle of that is the sweet spot of innovation, where you need to understand, is it technologically feasible? Is there a market? So will you be able to sell the product? Are you identifying customers that have needs and pain points that you can address? And the third thing is, can you make it profitable? So these are the things that have been driving the creation of the Think platform. And when we look at all the substances that we need, we start to understand what technology readiness level each of those systems have. Are there technologies readily available in the market which would allow us not to have to do the full research and develop, but maybe some configuration or customization? And that's where we came up also with a strategy of who could be our partners, and we've been developing the relationships from there on.
I'm talking with ThinkOrbital CEO Sebastian Asprella on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Sebastian, give me a little bit about your background. How did you get involved in this?
Yes. Well, first of all, it's a dream come true since a child, like most of us perhaps, looking up to the stars, in a way thinking, why would they left me here? Maybe that's my alien side. In the other hand, just fascinated with human, I think, intelligence and determination to access space, right? And I kind of grew up in the more consciously in the shuttle era period, and since a child I love building stuff, especially one of my good friends. We're still friends since we were 3 years old, just building anything like little cars and all. So I always had that sort of knack for creating things. And I studied electromechanics. It was a kind of a half-board school, and in the morning we had all the workshops. You can imagine, fairly cold, especially winter, but we did everything from drilling things to lading things to computer to electronics to electricity, even welding and a few other things as well. So I really like that side. But in my mind was, okay, well, if I understand how to build physically a product, how do you actually understand the human mind to understand if you actually are satisfying their needs? So I did a 1-year foundation in psychology. And then after that, I was like, okay, I kind of understand the human mind, not much perhaps, but I understand a little bit. I understand how to cut metal, but how do you commercialize things? And then I went and did a combined degree in business and accounting, so business administration. And that kind of round things off. And for over a decade and a half, my main focus has been as a technology leader, implementing different products. I delivered 18 software products. I stood up over 25 teams. I oversaw 500 million euros worth of expenditure, and it's been great. And in between all of that, I've been pro bono supporting other startups. But in my heart, I knew at some point I wanted to have my own creation, my own startup, and it had to be nowhere else other than aerospace. And surprisingly enough, with my experience and also on the side being part of this fora, as I mentioned earlier, in aerospace, also I'm quite passionate about robotics. There were so many transferable skills that supported ThinkOrbital's growth, that supported also the interaction we have with our partners. And again, as I mentioned, I met Boita over this obscure aerospace nerdy fora, and then since then we've been sort of building the team, and we have our third co-founder, retired colonel of the Air Force, Lee Rosen. Again, another wonderful individual, and he served for over 20 years in the U.S. Air Force, primarily on space technology, and also he was VP of launch for SpaceX, and also he had a few various different roles within SpaceX as well, with a lot of experience on launch, and also many other aspects around commercialization, both private and government, and yeah, we make such a great co-founding team, but we would not be here if it wasn't for the overall team. And again, I'm kind of going a little bit on a tangent, but it's part of the answer as well. Everyone in our team, is as quirky as we are, and as knowledgeable, and as passionate about the mission, and it's one of the main things I think that I enjoy with the role I have, the people that I work with, both internally and externally to ThinkOrbital.
You mentioned Orb 2 just a few moments ago, and you said that was the structure that's in the graphic behind you. So go a little bit more into detail about what Orb 2 is.
Yeah, absolutely, Tom. So Orb2 was basically orbital orb, so orb squared. That's the original name that we gave the platform. And as we evolved, we became very creative and we called it ThinkPlatform.
Mm-hmm.
And effectively, it's the core technologies around the ThinkPlatform are robotic manipulation. So you have dual robotic arms that actually pick up the panels, the segments that make the pressure vessel, and basically puts them into place. Then we have latching mechanisms that keep the panels in place as you go through the assembly process, these sort of soccer balls for those that cannot see the picture of this space infrastructure. And the latching mechanisms keep the panels in place, but so they also provide data and power.
Mm-hmm.
And the robotic process continues until it builds that sort of football or soccer. And the reason why we have that shape, in one hand, is because it gives you the highest volume per weight ratio, but it also gives you the lowest cross-section against micrometeorites, which is quite important, especially talking about space debris itself. Then that robotic arm, as it stands today, picks up an end effector with a welding gun. This is the electron beam welding technology. It's probably the best welding technology humanity has ever created, but it requires high vacuum, which means if you're doing it here on Earth, you need a huge vacuum chamber. Well, depending on what you want to do, it's been used to weld, I think, the F-14s, fighter jet plane wings, but it's quite costly to do here on Earth. But in space, it makes sense. We're operating high vacuum, and it has sort of quite a deep penetration and low heat dissipation as well. So it's really one of the best tools when it comes to welding itself. So then once you combine all of those elements, you end up with the shell. You end up with the space platform. And then adjacent to that, well, you have the inner fittings depending on the application. And if it's the ThinkPlatform 1, it would be annexed to another free flyer, so you don't need to add any other subsystems. But if you were to go for a free flyer, then you need power, attitude controlled, radiators, and all of the other elements, which are also some of them working ourselves, or we're actually working with other entities. We're not looking to be, to anal about vertical integration. I mean, there are some benefits there, but there's a lot of benefits as well of partnering with well-established companies that actually have products they have tested and they're space-rated products itself. So then once you finish and you complete the sphere, especially with the fittings, internal fittings, we would normally be providing the annual servicing as a minimum, but also we had some potential prospective customers that are interested for us to actually operate it as well, so they can focus on what they do best, which could be either research, technology development, and manufacturing, and a few other applications as well.
So what are the advantages and disadvantages to this construction method compared to, say, the inflatable, the Sierra Space large inflatable flexible environment, that life system? How do you compare and contrast with an inflatable system, which seems to be the way a lot of these companies are going?
Well, I think that's a great question. And I think the best way to answer it as well is that they are complementary. So I don't think they're mutually exclusive. So I'm quite fond of the technology, well, especially Sierra, that they're good friends of ours. And I know the people there quite well, and they're great individuals. They're working super hard. And I think their life model, which is I think what Tom we were talking about now, it's critical, especially when it comes to of the risk of having a gap between the decommissioning of the International Space Station, which was originally planned for 2024, now it's been pushed to 2030. So we need to, we at the US and the allies, we need to have presence in space. We need to have human presence in space. We need to have continued presence in space. And I think the life habitat will be able to provide that. It's very much focused on human-rated activities. And I think it has a lot of advantages because, you kind of do all the outfitting here on Earth. And when you actually expand it in space, you're already more or less operational to go. Whereas where we come in, we are not that focused or that hot on human-rated activities, but we could, take up one of the nodules and expand. So you could imagine this, Tom, if you wanted to go to space, you could be one of the professional astronauts, operators of the manufacturing facilities inside the ThinkPlatform, and you will be able to go back to a life habitat to be able to, enjoy much better amenities when it comes to fully focused human-rated activities. Where there's a lot of things that they're planning to do inside of life. So, I see it more as an augmentation, other than. I mean, we probably need both. I'm not sure did I answer your question?
Oh, absolutely. But then that begs the question: is how does that affect your design process when you think about being a complementary facility as opposed to maybe something that's standalone? How does that affect how you're designing ThinkPlatform?
Yeah, so and this is why we have this sort of the two major products, the ThinkPlatform 1 and 2. Mm-hmm. And I say this because we're also looking at productizing, if that's an English word, subsystems. So we're looking at being able to generate revenue before we are able to sell these major two products. And in terms of hopefully we'll be able to announce a lot more, but in terms of, for example, the relationship with some prospective collaborators or prospective customers like Sierra, we're looking at the ThinkPlatform 1, which is sort of the collocated sphere, for it to be able to be adaptable, for it to be able to, as I said, complement, expanding the possibilities that the live habitats or any of the other modules within the orbital reef would be able to provide. And the reason being why these are complementary also is because the way we are advancing our technology, it makes it very cost effective for non-human rated activities. It doesn't mean a human would not be able to actually float into the ThinkPlatform 1, mm-hmm. but we wouldn't cater, for example, for docking for life support systems. We wouldn't cater for a sort of full habitat inside the ThinkPlatform 1, but really hardcore, research, technology development, storage, which is an issue in the international spaces. We've seen it now, and as well as manufacturing and other activities, which would be better suited if they're separated in terms of its environment compared to where you're actually focusing on being able to support human life in space.
So more of an office building or warehouse as opposed to a luxury hotel.
That's a great analogy. Yes, that's a great analogy. Although they are planning to also do some research, but they look at the human presence itself. But if you don't mind, Tom, I'll probably use that analogy as well.
Okay, feel free. I'll let you. I'll give you free license on that one. But Sebastian,
it's important. Just very quickly, this is my understanding of life, and I don't want my friends from Sierra when they listen to the podcast to think, oh, but you missed this part, you missed the other part. This is my humble understanding of life. I know it has a lot of potential.
But let me go back to the capacity issue for a moment. Does the industry really have adequate standards right now to address the capacity situation? And I'm thinking along the lines of communications, docking, the things that you will need to make all of these different pieces work together. And if not, what are the standards in your mind that need to be created?
Unfortunately, we're not at the stage where we have standards for most of the things that you have mentioned, or probably, as far as I'm aware, not at all. But it's something that I know for a fact that there's quite a lot of people that are working towards having these standards. And I think the need for standards it's obvious, especially when we look at interoperability between different modules, different companies, etc. And I do know, for example, when it comes to refueling, there is a startup that I'm very fond of, and also their CEO, who's great, Daniel Faber from Orbit Fab. I'm not sure if you heard about them. They're trying to standardize when it comes to the refueling, and I think that things like this they may seem simpler, but it's very complex, right? To get it's like herding cats in a way, to get everybody to agree on a particular standard. But it's critical for us to be able to scale in space. Otherwise, imagine a situation where you want to refuel and you need to carry 3 or 4 different type of, inlets. It would be crazy, and especially also when it comes to, docking adapters and what have you. So this is an area that that we are looking quite closely. We are supporting a little bit from the sidelines at this stage. We're looking at what standard organization we may be able to support best, but we are collaborating with those that are engaged with those organizations at this stage. But yeah, absolutely critical.
Sebastian, we're just about out of time, but I want to ask you kind of our exit question that we ask all of our guests, and that's to look out over the next 10 to 15 years in space commerce and tell me what you see.
Well, I see a renaissance of space. I see a shift between what we're working towards, this historical mindset of scarcity, of over-engineering product, looking at the most expensive, lighter materials, not a lot of space, because you don't have a lot of space in the rocket fairing, because you don't have a lot of space in international space stations. So that shift in paradigm to a future of abundance, where you can launch with high regularity, high cadence, high reliability. You can launch a lot of materials with Starship and what have you, and you have a lot of space. You have the free flyers, the commercial LEO destination free flyers and Axiom operating in space, really opening up the frontier, and the likes of ThinkPlatform and many other startups providing a platform for manufacturing industry to commercialize space, to be able to lift heavy industry, hopefully off Earth, and we'll start looking more and more after our planet, but also technologies that would be able to do power generation and a few others that we're thinking about when you master the assembly process in space, that would also help with regards to climate change. So I think the future is bright. I'm super excited, and I'm kind of enjoying it every day, I would say.
It's been fascinating, Sebastian. Thank you so much for joining me today.
Thank you, Tom, and thank you to your audience as well. And if anybody wants to reach out to me, I'm active on LinkedIn primarily, and I love to hear, thoughts, feedback, and the support we've been getting so far has been phenomenal.
We'll be sure to include that link. Thanks so much.
Thank you, Tom.
Sebastian Asprella is the CEO of Think Orbital, and that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, like Galileo through his looking glass. Thirst for reason. A dreamer's eyes we gaze into, a sense of purpose, know my view. Like finding water on the moon.